Hello everyone, I am Dr. SHRUTI DIXIT, Associate Professor in Electronics and Communication Department, Sagar Institute of Research and Technology, Bhopal. This college is under the SAGE group. Today's topic of discussion is modes of transfer from the subject computer system organization. This is unit 3 topic of semester 5th under the RGPV syllabus. Modes of transfer. Data transfer can be handled in one of the three modes: programmed input-output, interrupt initiated input-output, and direct memory access. In short, it is known as DM. In this topic, how the data will be transmitted from the transmitter to receiver, we will see. In case of program input-output, each data item transfer is initiated by an input-output instruction written in a computer program. Transferring data under program control requires constant monitoring of the peripheral by CPU. This is the biggest disadvantage of this method. And to overcome this disadvantage, we will discuss interrupt initiated and DMA technique. In program input-output method, the CPU stays in a program loop until input-output unit is ready for data transfer. This is very time-consuming process, and in this method, the processor uselessly or needlessly busy and stays in a loop. Data transfer initiated by an instruction in the program from CPU register to the peripheral device. This is bidirectional process. And again, CPU to memory, again, this is the bidirectional process. The peripheral has to be constantly monitored by the CPU. Once a data transfer is initiated, the CPU is required to monitor the interface to see when a transfer can again be made. This is the example of data transfer from an input-output device through an interface into a CPU is given below. Here, input-output device and CPU are there. The main communication between these two entities. First, as soon as the input-output device has the data, it will transfer its data through the data bus. And this is the unidirectional signal, and the direction will be from input output device to this interface. Then the data valid signal will be transmitted from the input output device to the interface. The data register will be filled by this data, which is transmitted by the input output device. And the status register, the value of flag will be 1. At this time, the whenever the value of flag f is equals to 1, the data accepted signal will be transmitted from this interface to the input output device. And at that time, whenever the value of f is equals to 1, no data will be transmitted through the data bus. These are data bus and data valid signals will be disabled. Then the CPU will take the data through this data bus. This is the address bus, and input output read from the keyboard, and for the printer input output write signal will be there. The transfer of each byte requires 3 important instructions: read the status register, check the status of the flag bit, and branch to step 1 if not set, or to step 3 if set. Set means f is equals to 1 and not set means f is equals to 0. And read the data register. And whenever the data register will be empty, the data accepted will signal from interface to input output device will be disabled, and the then the input output device will send its data through this data bus. Means data bus and data valid signals will be enabled whenever the data accepted signal will be disabled. This is the flow chart for these program input output. The checking of flag bit f is equals to 1 whenever the value of flag is 1. The status register will be read by this CPU and transfers data to the memory, and operation will, if operation will complete, then continue with program. If operation will not be completed, then again the data register value will be read. Now, whenever the flag value will be 0, again continuously the data register value will be read by this CPU. These are the 4 important applications of this program input output. It is generally preferable for small low speed computers because CPU has to be continuously stays in the loop, and it has to monitor the input output device whether it is sending data or not. In systems that are dedicated to monitor a device continuously, which is the advantage of this program input output method, in the data register, continuously in the data register, to check the status of the flag bit and branch. The main disadvantage of this method is that the CPU has to be continuously stays in the loop, and it has to check the flag register value and check the input, whether the input output device is sending data or not. To overcome this disadvantage, the interrupt initiated method is there. In the next lecture, we will discuss about the interrupt initiated method. Thank you so much.